Right, here are the solutions to the C3 paper, the R paper from summer 2013. Question number 1 asks you to express this as a single fraction in its simplified form. So it's a question of factorising x squared plus x minus 12, realising that there's a common factor in the denominator which is x minus 3, so the 2 has to be multiplied by x plus 4, that x plus 4 has to be multiplied there. The only tricky thing really is that minus 2 times plus 4 is minus 8, so 5 minus 8 is minus 3. The x minus 3 cancels and you're left with 1 over x plus 4. In question 2 you have to sketch two curves. The first one is f of 2x, so the transformation is a stretch scale factor of half, or a squash if you like. So that's why this point here is at 0.5, whereas before it was at 1. Part B is the modulus of f of x, so whereas the original graph came down here, the negative part gets reflected in the x-axis. This point stays the same, 1, 0, and it's important to note that the third mark is given for a cusp, not a minimum point. So this has to be a pointy bit. It's not a minimum point, it doesn't curve round like that. It comes down to a point and then goes up. So that's called a cusp. In question 3 we have to write this equation in the form r cos x minus a. So let's write out r cos x minus a, cos x cos a plus sin x sin a. So we can compare the two cos x's, which means cos a is 7 over root 50, which means a is 8.1 degrees to one decimal place. We need to find the exact value of r, so 7 squared plus 1 squared, take the square root, that's root 50. So that's root 50 or 5 root 2, either answer is acceptable. And we have to give a to one decimal place, that's 8.1 degrees. In part B we've got to solve the equation 7 cos x plus sin x is 5. We know what 7 cos x plus sin x is. It's root 50 cos x minus a, 8.1301. So it's basically solving this equation because we've already done this. We've already written 7 cos x plus sin x in this format. So divide both sides by root 50, do inverse cos. Don't forget there's more than one answer. So 45 and 315, inverse cos of 5 over root 50 is 45, 315, there's other answers, but these are the only two that lie within the range once we've added 8.13 to them. So 45 plus 8.13, 315 plus 8.13, and we get your two answers, 53.1 and 323.1. In part C we need to find the value of k for which this expression has only one solution. So we go through the same process as before, get to this situation here. Cosine of something, we've got k over root 50 this time. If there's only one solution, then the cosine has to be plus 1 or minus 1, because the cosine graph has maximum and minimum points at 1 and minus 1. So the only two values between 0 and 360 which have just one solution are plus 1 and minus 1. So the cosine of that is plus or minus 1, so k must be plus or minus root 50. Plus root 50 over root 50 is plus 1, minus root 50 over root 50 is minus 1. So k is plus or minus root 50 to give us our two solutions. In question 4 we've got this function, 2 mod x plus 3, and we need to find the range of f. Well, the modulus of x is positive values only, so the smallest value is 0 and the biggest value is infinite. So if you times that by 2 and add 3, then we get values greater than or equal to 3. So we've got the range, which we need to write as f of x, is greater than or equal to 3. In part B, f of g of 1 means do g first, so put 1 into g, so it's 3 minus 4 times 1. Now there's a method mark for that, so it must be clear what you're doing here. So writing that line out, or that section out there, is what you need to do to get your method mark. That works out to be minus 1. Put minus 1 into f. The modulus of minus 1 is 1, so we get 5. In part C, Let's just move this up a little bit. There we go. In part C, then we need to find the inverse function of g. So we write y equal to 3 minus 4x, rearrange to get x in terms of y, and then replace the y by x. So it's a method mark for swapping the x and y, and to finish x equals. And that's your answer. In part D, we've got to solve this equation. So g of x means put x into g, it's that bit there in the bracket, that's g of x, and then do g again, 3 minus 4 of that. But g of x squared means work out g of x, 3 minus 4x, and square it. You need to solve this equation. So multiply out, beware that minus times a minus gives you a plus there, rearrange, and then we get those two solutions. Here's question 5. It firstly asks us to differentiate this expression. It doesn't say simplify, so leaving it in this format is fine. There is a mark for use of the quotient rule, so the best way to get that mark is to quote the quotient rule. If you don't quote that, and then it's not clear what you're doing here, and you make a mistake, you won't even get the method mark. But there's a method mark for writing that rule down, which is in the formula book. But you don't need to simplify, so that's okay. Part B asks us to write d by dx of sec squared 3x in that particular form. Sec squared 3x, that's sec 3x squared, so it's 2 times that bracket to the power 1. Then differentiate the bracket, sec goes to sec tan, 3x differentiates to 3. 2 times 3 is 6, there's a sec squared. Now sec squared is 1 plus tan squared, so to get that method mark, to make it absolutely clear, I've written what I've used there. 1 plus tan squared is sec squared, and then it rearranges to get this. So it can be written in this format. So it's important that the last line is that there with, instead of the mu, we've got the 6. Now let's look at part C. We've got x is 2 sine y over 3. So let's differentiate. Sine differentiates to cos, y over 3 differentiates to 1 over 3, and there was a 2 there anyway. But sine squared and cos squared is 1, so instead of writing cos, I can write the square root of 1 minus sine squared. There's the square root there, it's 1 minus sine squared. But sine y over 3 is x over 2 from here. Divide both sides by 2. Sine y over 3 is x over 2. So instead of writing sine squared y over 3, I can write x squared over 4. Let's put this all over one denominator. It's 4 minus x squared over 4. The square root of 4 is 2, so that's where that 2 has come from. It's 2/3. Square root of 4 is 2, and I've got that part there. Let's move up a little bit. And then the 2's cancel. 1 over 3 is a third. And then dy by dx is 1 over dx by dy. And then we get our answer. Here's question 6. When using sine 2x is 2 sine x cos x, so cosec 2x is 1 over sine 2x, and sine 2x is 2 sine x cos x, so it's 1 over 2, that's a half. 1 over sine is cosec, 1 over cos is sec, so lambda is a half. It does say state the value of lambda, so at the end I've stated that. In part 2 we've got to solve this equation. I'm going to use the fact that 1 plus tan squared is sec squared, so instead of writing 2 tan squared, I can write 2 sec squared minus 2. So I've quoted that rule to get my method mark, which kicks in down here. So 3 sec squared is there, 3 sec is there, and instead of 2 tan squared it's 2 sec squared minus 2. Rearrange, quadratic in sec, get sec theta is minus 1 or minus 2, so cos is 1 over that, so therefore theta, there we go, therefore solution of that is theta is pi, or 2 pi by 3, or 4 pi by 3. I'll just write it all out at the end. For question 7, in part A, we need to find the coordinates where f of x is 0. So I've written f of x is 0. E to the power is never 0, so I can divide by e to the x squared, quadratic in x, solve that, give the answer to 3 decimal places. In part B, we need to differentiate the expression. So I need to differentiate this expression here. It's a product, so I've quoted the product rule to get my method mark in case I make a mistake. Leave e to the x squared alone and differentiate x squared plus 3x plus 1, and then vice versa. Differentiate e to the x squared is 2x. It doesn't say simplify, so I'm going to leave it like that. No point in spending time doing unnecessary work. If it said simplify, I'd have to start factorising with e to the x squared and multiplying out, which actually is what you were going to do in the next part anyway. So f dash x is 0. That's a minimum turning point. So I've put the whole expression equal to 0. E to the x squared is a factor, but e to the x squared can't be 0. So the bit that's left is 0. 2x plus 3 plus x squared plus 3x plus 1 times 2x. Don't forget that x. So therefore I get that expression there. Now at this point it's important to look at the final answer to see what we're looking for. I want a minus 3 times 2x squared plus 1. So that's minus 6x squared plus 3. So 6x squared plus 3, if I take 6x squared plus 3 over that side, that minus 3 over 2x squared plus 1 from these two terms, that's going to give me the top line. What's left is 2x cubed plus 4x, and that factorises. So I can now divide by 2x squared plus 4 to give that expression here. So at this stage it's not necessarily obvious what you do. There's lots of ways we could get an iteration, but by looking at the solution I can see that I need to get minus 3 times 2x squared plus 1. Well, those two terms are 3 times 2x squared plus 1. So that's why I can pull those over. It does say show, so because it says show, I'm just going to write that out again at the end. Now we have part D, so we need to use the iteration that we've just got with x is minus 2.4 and to put that into those that expression, 3 2xn squared plus 1 over 2xn squared plus 2. I get those solutions. The answers have to be to 3 decimal places. It's not very straightforward to get these, so you do need to check if you got wildly differing answers that were diverging rather than converging. You know you'd have made a mistake. These answers always converge on an answer. And then to find in part E, to prove that alpha is minus 2.43, I'm going to take minus 2.425 and minus 2.435. It's important to remember which equation we're solving. We're trying to find where the minimum turning point is, so it's f dash x is 0. It's not f of x is 0. We're trying to find alpha, the minimum turning point. So therefore it's this that's 0. So if I substitute in minus 2.425 into this and minus 2.435 into that, I get those answers. And then you write out the boring sentence at the end. Now for question 8. In question 8 we want to find the population when t is 0 at the start of the study. So put t is 0 into this expression, you get 1000. Part B, the expected upper limit. So as t goes on and on and on, as t gets bigger and bigger and bigger, what happens to this value? Well, as t approaches infinity, e to the minus kt approaches 0. 1 over a very, very large number is 0. So I can replace 7 times 0 by 0. So it's 8000 over 1 plus 0, that's 8000. In part C, we're told that when t is 3, p is 2500. So substitute those values into there. Bit of cross multiplication, take away 1, divide by 7, do a ln, work out the answer, and you get 0.386. So straightforward equation to solve, but obviously need to be careful with your calculations. And finally in part D, well finally parts D and E, when t equals 10, let's put t equals 10 into there. It does say use the original value for k, 0.386, not the full answer or the answer to 8 decimal places, but to 3 decimal places. You've got to do that for both these parts here. So put in t equals 10 and we get that answer here to 3 sig figs. And in part E we want the rate, so the rate is dp by dt, so we need to differentiate. So it's a power to the minus 1, so it's minus that to the minus 2, then differentiate the bracket. The minus k comes down, so it's minus 7k e to the minus kt. Plug in t is 10 and k is 0.386, and you get 346. And that's the C3 Summer 2013 R paper.